Hello, welcome. My name is Elise. I'm on the product team here at Databricks, joined by Peter, also on the product team. And we are super excited to chat with you about Lakeflow Connect. Just as a reminder, the session is for informational purposes only. A lot of what you see today is already in production, and there will be a sign up for our waitlist at the very end of this talk, but a lot of it is still in progress. So, we're going to continue iterating based on your feedback. All right, so if you just came from the keynote, you heard Bilal talk about Lakeflow, which is a new unified solution for data engineering across ingestion, transformation, and orchestration. During this chat, we are going to focus on ingestion. Specifically, we're going to start with sort of a state of the union. What are our existing ingestion products? From there, we're going to talk about Lakeflow Connect and how it fits into that portfolio. We're going to demo the product, and we're going to talk to you about what's powering that demo under the hood. And then finally, we're going to proactively answer a lot of the questions that we've been getting from customers like you. We may actually have time to field some live questions, so we'll try to do that. But if we can't, we'll be in the room, in the hallway. You can catch us after. We're also glad to do one-on-one chats after Summit. To start, why are we here today? Oh, we've heard about a ton of amazing products this week, but before you can take advantage of any of them, you have to access your data. And that data is probably all over the place, right? You have SaaS applications, you have databases, bonus points if your databases are on-prem. You have message buses, file sources, APIs, and it can be really hard to get all that data into the lakehouse so that you can do interesting things with it. To start, SaaS APIs, they're super hard to ramp up on. They're full of edge cases. They change all the time, right? So it's really hard to keep up with them too. Database pipelines are arguably even harder to configure and to maintain, especially without impacting the source system. At the end of the day, you spend a lot of time building pipelines, optimizing them, and particularly maintaining them. And this gets really expensive over time, and it just slows your time to value. It doesn't help that a lot of these pipelines require specialized data engineers, and those engineers are in really, really high demand and short supply. So their work is piling up, and then meanwhile, the people who actually need to use this data, the HR analyst, the financial planner, maybe the product manager, they're all blocked. And it's really the opposite of data democratization. And you might not even want to democratize the data when you have a patchwork of ingestion solutions, because it's really, really hard to govern it effectively. It's hard to orchestrate it, it's hard to oversee it, things like access control and lineage and monitoring and so on. So at the end of the day, you're not fully utilizing your data. You probably have pipeline outages all the time, and you may even have security risks. So Databricks has already done a lot of work to try to solve this problem, and we want to talk about some of those existing solutions to help contextualize where Lakeflow Connect fits into that. To start, there was structured streaming. Structured streaming is an API for incremental stream processing in near real time. And engineers love it for the performance and the scalability and the fault tolerance. But over time, they wanted more automation. They also wanted less overhead. They wanted things like better auto-scaling, data quality controls, failure recovery, and so on. So Databricks introduced Delta Live tables. DLT is a declarative framework for building reliable and scalable data pipelines. You tell DLT what transformations you want to perform on your data, and DLT takes care of orchestration and monitoring and data quality and errors. And customers love that it reduced a lot of that complexity we've been talking about, while also really improving the performance of your pipelines. So what's next? Well, these days, we're hearing a lot of demand for something that is even more managed and even simpler, especially when you're dealing with those complex data sources. You don't want to learn about the SaaS APIs and all of their fun edge cases. You don't want to think about the networking complexity of your databases. You don't want to get paged in the middle of the night because your pipelines went down after you hit a bunch of API limits. We're also hearing that more people than ever want to access that data, right? The HR analyst, the product manager. And they may even be willing to pull it themselves if we give them a way to do it and if it gets them closer to their goal more quickly. So that is why we are introducing Lakeflow Connect. This is a series of native ingestion connectors that are really intended for any data practitioner to be able to build incremental data pipelines at scale. It includes connectors for SaaS applications, for databases, and for file sources. And to really explain the product, we want to talk about three things. The first is simplicity. The second, unification. And the third is efficiency. To start, these connectors are really, really simple to set up, which you're going to see when Peter demos it in just a couple of minutes. And once a connector is set up, it's also really easy to maintain. Essentially, insofar as Databricks has the permissions to deal with a problem, Databricks holds the pager when something goes wrong. That reduces your management costs, and it also more generally means you get to spend less time thinking about how to move your data and more time actually getting value from that data. Practically, we're going to be offering things like schema evolution, robust observability and alerting, automated retries and error handling, automated connector upgrades when the third-party APIs change, SCD type 1 and type 2, and this list is going to get quite a bit longer. It's an iterative product. For example, we're also going to be adding schema mapping, data sampling, time travel, change data feeds, even more robust schema evolution. That's going to be quite iterative. And at the end of the day, we also wrap this up into a really simple UI and a really simple API. And we think all of that is exciting in its own right, but you might be thinking to yourself, well, every provider is trying to do simple, low-maintenance ingestion. It's almost table stakes these days, which is why we need more. Specifically, we're also focusing on unifying with the rest of your Databricks tooling. This product is governed by Unity Catalog, it's orchestrated in workflows, and it's powered by serverless Delta Live tables. So you don't need to learn a new tool to do your ingestion. And you can do ingestion in the same place where you might already be doing orchestration and analytics and ML. So for example, do you want to track the lineage of your ingested data? That's coming with Unity Catalog. Do you want to add a notebook that automatically detects PII as soon as your data lands in that bronze layer? You can do that in workflows. Do you want to limit how much your data travels across different clouds and different accounts? Well, because we're keeping everything in your account, you get less data transfer, which means more computational efficiency. Our goal here is to basically help you take advantage of the reasons you chose a lakehouse in the first place and to fit really seamlessly with your existing workflows. But what might be truly special is how we handle incrementalization. These pipelines are efficient at reading and writing and transforming your data downstream, which ultimately translates to the performance and cost of your pipelines. So for example, we incrementally read the data. Where possible, we are not reading everything and applying some sort of diff. When we have it, we are just going to read the data that's actually changed. And we should mention that there's no blanket approach to doing that. We are generally optimizing it for each source and sometimes even for each table. But incrementalization doesn't stop at reading. We also generally incrementally write the data. And that means that you'll be able to use change data feeds to capture a history of those changes, in addition to the SCD2 stuff. And ingestion is really just step one, right? So we don't want to just stop there. We also write the data to support incremental processing downstream as it works its way through the medallion architecture. So for example, if you want to create a materialized view to do downstream transformations, features like Enzyme can incrementally update your view so that you're only ever updating the rows that actually need to change based on whatever changed in the input. The alternative is to fully recompute those views every single time. But with data constantly coming in through these ingestion connectors, that can get pretty cost prohibitive. Enzyme is also smart about how it does those computations, which is what you're seeing here. It uses a cost model to pick the fastest technique from a list of available techniques for a given view so that you get better performance of that ETL. In fact, the team recently did some benchmarking, and they benchmarked a 200 billion row materialized view using Enzyme and one that wasn't. And they saw that Enzyme got them up to 340 times better price performance compared to fully recomputing that view. Even at smaller scale, you're going to see some of those performance improvements. And ultimately, this just makes your end-to-end ETL just that much more efficient. This is a highly iterative roadmap, both in terms of the connectors that we offer and the features that are in every single connector. We already actually have several connectors in preview. We have Salesforce Sales Cloud, we have Workday Reports, we have Azure SQL DB, and we have AWS RDS for SQL Server. If you'd like to join any of these current or future previews, reach out to your Databricks account team. You'll also see a wait list to join those SaaS connector previews at the end of this talk. But more broadly, the list is going to get pretty long, and it's going to depend on the features that you ask for and the sources that you want us to build. So there will also be a survey asking you which sources you would like in the platform at the end of this talk. All right, that is enough talking. Peter's going to come up here, and he's going to actually demo the product, and then he's going to talk to you about what is happening under the hood.
Thanks, Elise. I'm excited to show everyone just how easy it is to use Lakeflow Connect. And I'm going to start off by setting the scene for the demo. In this case, I don't own a cookie company, but I'm a data engineer for a car company called Speedy Motors. And my organization has data across a bunch of different sources, which include Salesforce and SQL Server. And the data quality in these sources, it kind of varies. Some is low quality, some is high quality, but I want to make sure I'm not providing low quality data that negatively impacts my organization. Ultimately, I want to make sure my organization has high quality data that they can use to make informed decisions. I want to be able to generate dashboards that are updated with the latest data to share insights with my stakeholders. And I want to be able to leverage AI to help my sales team generate sales plans using all of the data that my organization has about our customers and about our products. And before Lakeflow, how might I ingest this data? I could use a combination of different tools. I might have extraction software, which is running on a virtual machine. And that means I now need to allocate infrastructure. I need to think about the scale of that infrastructure. And I also need to worry about actually updating the operating system. So it's going to be a lot of work for me. I could also then create a message bus, which is capturing all of the changes from the sources. And finally, I might write some custom code in a notebook to capture all of those changes from the message bus and apply my data into the lakehouse. So all of this probably works. It's just going to take me a very long time to set up. I'm going to be responsible for all of the ongoing maintenance. And if any of the sources have an API change, it might break my entire flow, and I'm going to have to start all over again. So that's why I'm very excited about Lakeflow Connect. I no longer need to think about that complexity. I just worry about what data do I actually want to bring into the lakehouse, and then what do I want to do with that data. So I'm going to show you a demo. I had previously recorded this, but it is using the real Salesforce and SQL Server Lakeflow Connect. And I'm just going to walk you through the scenario for my organization. So to get started, I'm in the Databricks UI on the Add Data page. And here I can see the variety of different database and SaaS application sources that are available for me to ingest from. And first, I'm going to click on Salesforce to ingest from that instance. When I click on the Salesforce icon, I'm brought into the connector wizard, which has just 4 steps to begin ingesting my data. All of these steps can be completed within the UI. I don't actually have to write any code to create a scalable and efficient data pipeline, though we are also going to make a managed API available for those that want to use it. So I can first provide a custom name for my pipeline. Here it's called Salesforce Ingest Pipeline. And then I select an existing Unity catalog connection that I have to my Salesforce instance. In this case, it's called Speedy Motors Connection. And if I didn't already have a connection created, I could quickly click on the Create Connection button and authenticate to Salesforce using OAuth. And once I have a name and connection, I'm ready to begin the creation of my pipeline. So my pipeline will do some initial validation and setup, and once that's completed, I can click Next to begin selecting the source objects that I would like to ingest. And I'm able to browse all of the objects that are available from my Salesforce instance. And I can select to either ingest only certain objects or all of the objects from my Salesforce instance. And in this use case, I need 3 specific objects: account, product, and opportunity. So I can search for those and select them. And additionally, as the schema evolves on these tables, it will be represented in the Lakehouse target. Initially, we're going to support new columns, and then we're going to further expand it to support even more complex schema evolution. Next, it's time to decide where my data goes. So I already have an existing catalog and schema that I want to add my Salesforce data to. I can just search for it and then select the specific schema. Alternatively, if I want to create a new destination right here, I could just click on the Add Schema button. And in the future, we're going to even expand this functionality to support things such as renaming the tables or being able to drag and drop those tables into different schemas. And when the pipeline finishes setting up, I'm going to land on my new pipelines monitoring DAG, where I can see the status of the ingested Salesforce objects. And these are all going to be represented as streaming tables. And these streaming tables are what enable Lakeflow Connect to have that very efficient and incremental update as they happen from the source objects. Additionally, I'm going to set a schedule for this pipeline so I can decide how fresh I want the data. In this case, I'm going to schedule it to run once every hour. And on database sources, we're also going to support continuous ingestion in the future. Additionally, I can also choose to enable notifications on my ingestion pipeline. So this is going to let me know my pipeline started successfully, has completed, or has some sort of failure. So as you can see there, it's very quick and easy to get started ingesting incremental data from Salesforce into the Lakehouse. And now that I have that data, how am I actually going to leverage it to meet my organization's goals? As you can see in this diagram here, I have a couple of tasks that I'm going to complete to transform my data and then eventually share it with my stakeholders. So if you look in the diagram right here, so as you look at the diagram right here, I'm first ingesting my data, both from Salesforce and SQL Server. I had already set up a SQL Server connector behind the scenes where we're ingesting inventory data from my car dealerships. And then I'm going to set up a DLT pipeline in the middle where we have the bronze, silver, and gold layers representing the medallion architecture. And in this DLT pipeline, I'm going to transform, aggregate, and improve the quality of my data. And once I have that high quality curated data, I'm able to create an AI BI dashboard and provide visualizations and insights to my organization. In addition, I can also generate a RAG application, as you can see on the top right there, using the data as it's ingested or after it's transformed and cleaned up. So now I'm going to show some of that transformation and actually showcasing it in a dashboard and the RAG model. So to complete this aggregation, transformation, and data quality improvements, I created the DLT pipeline. And as you can see in the DAG of this DLT pipeline, I'm joining and cleaning data both from Salesforce and SQL Server. And I'm creating materialized views to represent the bronze, silver, and gold layers. And as incremental changes are applied to my streaming tables, the materialized views are going to be reflected to update the most recent data And with Enzyme, that's going to happen very quick and efficiently. For example of how easy this pipeline is to set up, I'm able to quickly create the aggregated product data materialized view by combining the product data from Salesforce alongside product reviews. And using a simple declarative SQL statement, I'm able to drop all of the low quality reviews, so cars with no name, calculate the average rating for each car, and attach this data to the cars available at each dealership. And once I have that materialized view, I can go to my AI BI dashboard and leverage that high quality curated data. I can create a bunch of visualizations to showcase different aspects of my organization. For example, I'm showcasing the inventory of cars across different dealerships. But I can also show all of the revenue generated, all of the available sales opportunities for cars, the average rating I calculated in the transformation, and then even show some of the comments that are actually coming from those car reviews. And since Lakeflow connectors are optimized for incremental loads and efficiency, this dashboard will be refreshed as new data flows from Salesforce and SQL Server. And the fact that this data is current makes the analytical information very actionable. So I could choose to move inventory from one dealership to another. And to show this in action, I'm going to update the inventory at a specific dealership to reflect more cars on my SQL Server database. And then once I complete this, it should update in my AI BI dashboard. So coming back, I would do a simple refresh on that dashboard, and I can now see there's 100 each of the Cosmos and Solstice cars. And then lastly, I'm actually going to want to create a RAG application that uses that data that I've ingested from Salesforce and SQL Server to help my sales team generate sales plans. And to start off, I created this workflow, which starts with my Salesforce and SQL Server ingestion jobs. When these jobs are completed, that DLT pipeline I had set up for ETL will be triggered, and it will start cleaning up my data and doing some of those transformations. And finally, I have a task to update a feature table that I'm going to use for my vector search index in my RAG application. And then I can navigate to that feature table in Catalog Explorer and click on the Create Vector Search button. I then simply provide a name for my vector search index, pick a primary key, an endpoint, and I can select to have my embeddings automatically computed, choose a column, and then search for a specific embedding model. In this case, I'm using a Databricks embedding model. And I can choose to run this as either triggered or continuous. In this case, I'm going to choose to run it as continuous. So as new data is ingested from Salesforce and SQL Server, my RAG application is going to stay up to date, and it's going to provide the best recommendations for my customers. So once that's created, I can see the status of all of the items that have been processed from my feature table in my vector index. And now I can actually navigate to a notebook to begin creating the RAG chain using the generated vector index, which you can see right here, a large language model, I'm using DBRX, and then a prompt template to help me determine my buyer's preferences and a description of what car they should actually purchase. And once I've created that RAG chain, I can actually invoke it to determine what car I should recommend for a specific buyer. And since I'm ingesting fresh data from Salesforce, I can actually get the latest account information for a specific buyer and use that as the input for my application. In this case, I'm querying for Alex Roberts, and I'm going to get their most up-to-date preferences. And after I run that RAG chain, I can see he likes to go hiking every weekend, he likes to be in the mountains, and I'm recommended that he should purchase a Pulsar PX300. Since it has all-wheel drive, it's probably great for the mountains. And as new products are incrementally ingested from Salesforce, this recommendation could change because we're always going to have that latest and up-to-date data informing our RAG application. So now that you saw the demo, let's dig a bit deeper into what's actually under the hood of a Lakeflow connector. So behind the scenes, we are leveraging the powerful capabilities of existing Databricks technologies. So these include UC connections, DLT pipelines, and workflows. The Unity catalog connections make it easy to manage credentials and govern who can actually set up the pipeline or edit the pipeline. The DLT pipelines make it possible to ingest incremental data very quickly and efficiently. And then our workflows enable me to actually schedule my ingestion pipelines and orchestrate them with other downstream tables. So let's specifically talk about connections first. As we know, networking can often be very complicated from these different sources. For most SaaS applications, the connections are relatively simple. You'll provide a host URL to actually connect to the SaaS application, and then some credentials, which will store securely in Unity Catalog. But for databases, it can be a little more complex. You often have databases secured with private endpoints or on-premise. It's really hard to get access to them. And we're excited to provide cloud-native networking opportunities for customers to connect to their database sources. So a customer can choose to connect to a database via a private endpoint if they have a peered VPC or virtual network in their workspace, or they can choose to connect directly to their database using private link from their source right into the Lakeflow connector. And now let's discuss how you're actually going to orchestrate all of this. There are two key things to know about ingestion pipeline orchestration, one being task types and the other being table triggers. Let's chat about tasks first. So every time you add a schedule to a given pipeline, we're automatically going to create a job for it, just like you saw in the demo. And then you can choose to add more tasks or jobs before or after that ingestion pipeline job. But you might have a bunch of different workflows that use that ingested data, and you're not going to want to keep ingesting that data over and over again. You might want to just kind of run it once and then connect it to a bunch of different workflows. And in that case, table triggers could be a better choice for you. These are a preview feature that are going to allow you to listen for updates on a specific table in order to trigger downstream actions. And they can also get pretty advanced. For example, you can set a minimum time after the last update before you trigger the workflow to run once again. So altogether, tasks and table triggers are a very powerful tool for end-to-end orchestration. So what does this actually all mean for the performance of the connector? We're still in the very early stages of development and testing, but we wanted to share some early results that we've seen from the Salesforce connector. And just like the cars in the earlier demo, your mileage may vary. These are not a guarantee, but we just wanted to share something early. And in the first two columns, you can see the number of objects we're actually ingesting from Salesforce, the total number of rows, and our observed latency. And as you can see, we've seen pretty strong performance for typical Salesforce instances. And for some of the larger instances where it does take a bit more time, we're doing a lot of optimizations to help improve the latency for those large workloads. And now I'm going to hand it back to Elise to talk about some of the most common customer questions about Lakeflow Connect.
First off, what is the relationship between Lakeflow Connect and Archeon? For context, Databricks acquired a company called Archeon in November of last year, and Archeon specializes in replication from databases, both cloud and on-prem. So as you can imagine, this platform is powered by Archeon, both their tech and their expertise. But we don't want to force you to use different products to ingest from different sources, right? That's the whole point of the unification. So Archeon won't be a separate product, it won't be a separate brand, it won't be a separate SKU. it will be powering a lot of what you see in the platform. Next, what's the relationship with Autoloader? Autoloader provides a structured streaming source called Cloud Files that allows you to incrementally ingest files from S3, ADLS, and GCS. And going back to our State of the Union, Autoloader is already compatible with several layers of the ETL portfolio. You can use it with structured streaming, and you can use it with DLT. So you can think of it as a cloud storage connector that works with different parts of our ETL portfolio. Over time, we may add support for managed autoloader as part of, I should say even more managed, as part of this connectors platform. So at that point, you're gonna have a managed S3 connector, a managed ADLS connector, and a managed GCS connector in the Lakeflow Connect platform in the same way that we have a Salesforce and a Workday connector today. Next, what is the relationship with Databricks ingestion partners? Our ingestion partners remain vital. They provide a really wide range of connectors that have really deep functionality that's maintained by dedicated teams of experienced engineers, and we need to continue to provide that option. So we will continue to support our ingestion partners in providing the widest range of connectors possible with the deepest possible functionality. We're just now adding the connectors that customers have asked us to put into our own platform, and then it's going to be up to customer choice. Finally, what is the relationship between Lakeflow Connect and Lakehouse Federation, or Delta sharing? For context, Lakehouse Federation allows you to query external data sources without actually moving your data. And Delta sharing allows you to share live data across clouds and platforms and accounts really securely. And a lot of customers do gravitate towards ingestion. A couple reasons. It can scale to accommodate very large data volumes, low latency querying, third-party API limits. But there's a ton of reasons you might want to use your data without actually moving it, right? For example, you might want to limit data duplication, or you want to only query live data. In that case, Delta sharing is the right approach for you. Or maybe you're going to be doing ad hoc reporting, proof of concept work, things like that. Lakehouse Federation can be simpler. At the end of the day, when you do have the option for both a federation or an ingest for a given source, I would recommend starting with federation. See if it satisfies your requirements. If it does, awesome. If it doesn't, you can always move to ingestion. That wraps up our chat on connectors. If there's one thing to take away, it's that we're offering these simple ingestion connectors that are also unified with the rest of your tooling and highly efficient. This is certainly not the only big thing we are launching in data engineering. Hopefully you caught some of these sessions earlier in the week. There's also a couple later today. This will all be recorded and posted on the Summit website as well, I think roughly 24 to 48 hours after the event ends. If you would like to take advantage of Lakeflow Connect, we do have a wait list for all of the SaaS connectors that are currently available. That's the first link right there. If you want to take advantage of the database connectors that are in preview, talk to your account team. And if you want to influence this roadmap, we have a survey on the second link here that I would love for everyone to fill out. If you could share what sources are important to you, there's also an opportunity to tell us that you'd like to connect one-on-one. We would love to talk to you, and we are reviewing every single entry that comes in through that survey. Thank you all so much. We're going to stick around if you have more questions. We'd love to continue chatting. And again, the links are, please fill out the survey.